Alrighty, let's look at some problems that will be similar to what you're going to see on your test. So number one, you need to know how to write a limit statement. A limit statement. For n behaviors, our limit statement is talking about which one of our different functional things. Well, I'll just tell you, it's talking about your horizontal asymptotes. N behavior is referring to your horizontal asymptotes. So there were three types of horizontal asymptotes. We had top-heavy functions, we had neutrally heavy functions, and we had bottom-heavy functions. Okay, so we found the n behavior of each of these three types of heavinesses when it comes to your rational function. Okay, so there are two ends. There's the left end and there's the right end, and you have to write them each correctly. So your left end limit uses the three letters of your word limit, so lim, as x arrow negative infinity. Okay, that's our left end behavior limit. Negative infinity as x decreases without bound. Okay, so that's how you start your limit on the left side for your n behavior. Okay, on the right side, that would be lim x arrow positive infinity. Okay, and then since our equation doesn't have a name, I guess we'll name this one A. So then you put the name of your equation here. Right, so notice that they're still lining up. You got to keep these things in line. The limits and your A and your answer are all on the same line, right? They're all at the same level. And then you have your x arrow infinity on a different level. Okay, and they're not on the same level, so don't put them on the same level. So our answer to our limit question comes from the heaviness. So looking at the heaviness of this function, is this top, bottom, or neutral? This is neutrally heavy because we have an x cubed over an x cubed. And whenever we have a neutrally heavy rational equation, we always look to the coefficients. So can we simplify, reduce, or divide 5 over 3? No, we cannot. So that becomes the answer to your limit problem. So 5/3. That is the equation of your horizontal asymptote. So that's the solution to your limit. So the limit of problem A is 5/3. Both the left and the right have the same limit. So part B wants us to do the same thing. So let's start with our limit statement. So here is our left end behavior limit statement, and here is our right end behavior limit statement. So now let's look at the heaviness. What is the heaviness of our rational function? This is a bottom heavy rational function because you have an x squared on the bottom and an x on top. So that means the horizontal asymptote is automatically y equals 0. So our limit answer is 0 for both of them, the left side and the right side. Okay, so now part number 2 is about when does f of x equal 0? Okay, so what does this mean? This means where does our graph cross the the x-axis? So we're looking for your x-intercept, which is also known as your 0, which is also known as your root, which is also known as your solution. There are lots of AKAs for when f of x equals 0, right? When does y equal 0? Well, we are looking for one place and one place only, and that's the numerator. Okay? Wherever the numerator equals 0, that's where we have your x-intercepts. So every time we have a quadratic, we're going to factor it. So let's factor the top and factor the bottom. Okay, so what does x squared minus 16 factor to? This is a special factorization of squares, so x minus 4 and x plus 4. Okay, x minus 4 and x plus 4. Those are numbers that multiply to give us negative 16 and add to give 0. Right, there's 0 x's in our equation. So multiply to give us negative 16 and add to give 0. How about the denominator? What numbers multiply to give us negative 6 and add to give negative 1? Okay, those numbers are negative 3 and positive 2. Okay, so we're factoring both the numerator and the denominator to see if any of these things cancel out. Okay, if something cancels out, then you don't have an intercept there. Instead, you have a hole. Okay, so here, nothing cancels out, which means you're looking directly at your numerator. We're going to solve both of these equations, so we set them both equal to 0. X minus 4 equals 0, and x plus 4 equals 0. You set each of your factors equal to 0. Okay, so this has an x-intercept or a root at positive 4 and at negative 4. So as a coordinate, that would be 4, 0 and negative 4, 0 if the question is asking you for the x-intercept. But it's just asking when is x equal to 0 or when is y equal to 0, so that is going to be a sufficient answer. Okay, I know it doesn't ask this, but what about the y-intercept? When is it cross the y-axis? Okay, so if you want to find the y-intercept, you get rid of all of your x's, and it's negative 16 over negative 6, which becomes, if we divide them by 2, positive 8 over 3. So the y-intercept is 0, 8 thirds. Okay, I know it doesn't ask about that, but your test might. So just in case, just so you know, if you want to find the y-intercept, plug in 0 for x. Okay, for b, we're not going to have any factors, so let's set this equal to 0. So what do each of our terms have in common? They all have an x. So let's see, this is x times x times x minus 2x times x plus x. So in solving, our first thing to do is find the common factors. So they all have an x in common. So that leaves me with an x squared minus 2x and then a plus. What happens if all the things are gone? You put a 1. If all of your things are gone, you put a 1. Because if I were to redistribute, I need to have something to multiply x by in order to get my original equation. So if all of your things get factored out, we have a 1 as the representative there left over. Perfect. Now we look at this. This is a quadratic, so we have to do a quadratic factorization. So we're asking ourselves, what numbers multiply to give us 1 and add to give negative 2? And the answers are negative 1 and negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So we have x as your common factor, and then our quadratic turns into x minus 1 and x minus 1. Okay, so this is completely factored, right? This is our complete factorization. Because once we have it factored, you set each of your factors equal to 0. And since there's 2 of these ones, you only have to do one of them. So this crosses our x-axis at 0 and at positive 1. Okay, so anytime you want to figure out when f of x equals 0, you're looking for your x-intercepts. So you factor, see if anything cancels, and then solve your numerator. So number 3, we have something written in very mathematical notation. So we have g is this equation, and f is this equation. But then h is what happens when we divide them. Okay, so let's first rewrite our h equation. Okay, so h is our f. F is x squared minus x minus 6, right? That's our f equation. What we were told here, this is our f equation. So where we see f, let's write down its actual equation. And then the g equation is x squared minus 4. Okay, so this is our rational equation written as a rational rather than as just functional notation, right? This is function notation. This is our actual equation. Okay, so what is the domain of h? Domain is talking about x terms. What x terms can we not use? Right? That's what we're trying to figure out when we're talking about domain. Right? We think about domain as like the dietary restrictions. What things can you not eat? Okay, I can eat anything in the world except for shellfish. Maybe you're allergic to shellfish, so you have to exclude shellfish from your diet. Well, we can't have any number that makes the denominator 0. Okay, that is something that we can't have in math. That is an undefined value. So we have to find all the numbers that make your denominator 0. So x squared minus 4, the denominator cannot be 0. And we're going to solve this just like it was an equal sign. So x squared cannot be positive 4, right, when we add positive 4 over there. And when we take the square root, what kind of answers do we get? Positives and negatives. So there are two numbers that we cannot use in our equation, and that's positive 2 and negative 2. Any other number, so all real values except for positive 2 and negative 2, anything that makes your denominator 0 has to be restricted from your domain. Okay, part B says write a limit, right? So once again, we have a limit statement to represent what happens on the left side of the whole, okay? So this is a very specific limit equation. So we're looking for the limit as x approaches some number from the left, right? And our equation is called h. So we're looking for what goes in that box and then what goes in this blob. Okay? So this should be on your 3x5 card. What goes in the box? Well, what goes in the box is the x coordinate of your whole. Okay, the x coordinate of the whole goes in the box part of our limit equation. And what goes in the blob? The y coordinate of your whole. So we have to figure out the x coordinate and the y coordinate of our whole. Okay? So let's go back up to our equation and remind ourselves how we do that. So here's our equation, x squared minus x minus 6 over x squared minus 4. Okay? So first of all, in order to do this, we have to factor our equations. We have to be in factored form before we can decide where the whole is. So let's take a moment and factor both of these. What numbers multiply to give us minus 6 and add to give minus 1? That was x minus 3 and x plus 2. And on the bottom, what numbers multiply to give us minus 4 and add to give 0? X minus 2 and x plus 2. So now that we have it in factored form, what factor do you see more than once? The x plus 2. So whatever factor gets repeated, this is where we're going to find the whole in our graph. Okay? And then whatever factor gets left over, this is where we're going to find your vertical asymptote. So that's the difference between your factors, the things that cancel, where your hole's going to be. So we're going to have a hole where x plus 2 equals 0. So we have a hole at -2. This is the number that goes in our box. So we come back in here and we put -2 in the box. So as x goes to -2 from the left, right, the left side of -2, the answer is the y-coordinate. So how do we find the y-coordinate if we know x equals -2? You plug -2 back into your equation. So we take the -2 that we found and you plug it back into your simplified equation. So this is your simplified equation because the x plus 2's cancel out. Okay, so the y-coordinate is -2 minus 3 divided by -2 minus 2. You take your x that you found and you plug it into your simplified equation to figure out what the y is. That's -5 divided by -4, which is positive 5/4. So this is the number that goes in your blob. This is the y-coordinate of your hole, 5/4. Okay, so this is the limit statement for a hole. You have the x-coordinate down here, and you have the y-coordinate right there. Okay, which is different than the vertical asymptote type of a limit. Okay, our next one says, what is the limit statement for a vertical asymptote? Well, that one's different, and it should be written down on your card so you don't have to memorize the difference, you just write it. So we still have lim as x approaches. Okay, once again, what goes in the box? The x value of the asymptote. Okay, the x value of your vertical asymptote goes into your box. So if you go back up to our equation, what did not cancel out? The x minus 2. So x minus 2 equals 0 means we have a vertical asymptote at x equals 2. So 2 goes in your box. Okay. Now the answer to our vertical asymptote is always a positive or negative infinity. So the question becomes, which one is it? Okay. So because we want the left side of our vertical asymptote, we're going to plug in a number to the left side into our equation. So pick a number a little bit to the left of positive 2, like, oh, I don't know, 1.9. Really, really close to 2, but not 2. Okay, we pick a number close to 2, and you plug it into your equation. So our equation was x minus 3 over x minus 2. Right? That was our equation up here, x minus 3 over x minus 2. So when I plug in a 1.9 in for my x, when I plug in 1.9, I get 1.9 minus 3. Is that a positive number or a negative number? That's a negative number. If I do 1.9 minus 2, is that a positive or a negative? That's a negative. So what's a negative divided by a negative? Always a positive. So my graph is going to go up on the left side of positive 2 because 1.9 gave me a positive value. Okay, so I can erase, well, both of these actually, because I don't need to have a positive in front of an infinity in order for it to be positive. Okay, so here are your two different types of limits to numbers. If this is a number as your x and a number as your y, that's a whole. And if this is a number and that's an infinity, that's a vertical asymptote. Okay, so finishing up here, what types of functions have slant asymptotes? When your equation is top heavy. Okay, a top heavy graph has a slant asymptote. So I'm going to change this to a 2 because you have one like that on your test. So in order to find the slant asymptote, we do long division. Okay, so 5x squared minus 2x plus 5, right? I changed it because I don't want it to be crazy. So in long division, we think 3x times what is 5x squared? And that answer is a fraction, 5/3, and an x. Of course, 5/3 and an x. So we distribute into both of these. 5/3 times 3 is 5x. And 5/3 times 1 is minus 5/3 x. And then we subtract. Okay, we have to subtract these values. So these ones are gone. 2 plus 5/3. So 5/3 is the same as 1 and 2/3, yes? So 2 minus 1 and 2/3 is just 1/3. And it's a negative plus 5. Okay, so how do we change a 3 into a 1/3? Well, we divide it by 9. So minus 1/9. So yours tomorrow to find this slant asymptote. Tomorrow to find the slant asymptote, you're going to have much nicer numbers. Okay, they're going to be whole numbers. They won't be tricky fractions. But just know that a slant asymptote is going to come from a top-heavy function. Okay? Do great, make your card, and know how to write a limit statement.